everyone. Thanks for coming to our Spring Distinguished Women in Stats seminar. Today we're pleased to introduce Dr. Jennie Brandt. She's a professor of sociology and stats here at UCLA. Her research is in social stratification and inequality, mobility, social demography, education, and methods for causal inference. Among many honors, she is also director of the California Center for Population Research and co-director of the Center for Social Stats here at UCLA. She is chair-elect of the methodology section of the American Sociological Association and an elected board member of the International Sociological Association Research Committee on Social Stratification and Mobility. Please join us in welcoming Dr. Brandt.
Thanks so much. Thanks for the invitation and for Sydney and Stephanie for organizing this. It's a really nice society that they've formed here, and I think it's a great idea to hold an event like this. And it's nice to see sociologists and statisticians in the same room, which is, it would be great to have more of these opportunities to bring this group together. So what I wanted to do today is kind of go through a decade-long journey, really, of exploring methods for uncovering important variation or heterogeneity in the events, the effects of events or interventions or what we call treatments in the causal inference literature. So I'm going to focus on treatment effect heterogeneity, and it's of interest for basic scientific understanding and also for designing optimal policies. And so the journey began really with a grant, as many journeys do, that was then followed by a second grant with UCLA, who was then at the University of Michigan, now at Princeton University, on what we called heterogeneous treatment effects in demographic research. And the basis of the project was that this recognition that an essential feature common to demographic phenomena is variation or variability across units of analysis. So social and behavioral sciences, such as sociology, economics, demography, are population sciences in the sense that they treat individual level variation as a subject of scientific inquiry rather than as a mere nuisance. So individuals differ not only in pre-treatment characteristics, or a lot of the characteristics that we think about when we're controlling for possible confounding of estimating treatment effects, or pre-treatment heterogeneity, but also in how they respond to a common treatment or an event or intervention. And this is the type of variability that we call treatment effect heterogeneity. And of course, there's a practical need to overlook some level of heterogeneity. So in any research setting, so analysts often look at differences by race or by gender, and by doing so, they somewhat implicitly assume homogeneity within those groups and focus on the heterogeneity across those groups, or differences between blacks and whites, or differences between men and women. So the treatment effect heterogeneity has important implications for social and behavioral research and for social policy. So the study of heterogeneity can yield important insights about how scarce resources are unequally distributed in society, how events differentially impact populations who have different expectations of the events occurring. They give insight into what may explain differential response to treatment, so some of the mechanisms that we might think explain the impact of the association between treatments and outcomes. And then if policymakers understand patterns of treatment effect heterogeneity, they can more effectively assign policies to maximize average outcomes and reduce costs. So our aim has been to demonstrate the usefulness of estimating heterogeneous treatment effects using particularly observational data when we don't have an experimental setting. So we're in the situation where we have potentially sources of selection bias, and with particular application to issues of social inequality, and to develop new statistical methods that enable us to more effectively or fruitfully look at treatment effects, heterogeneous treatment effects, particularly in demographic research. So the first paper that really got us started in this larger project was this paper that's now over a decade, well, it's over a decade old that we began working on it, but it was Who Benefits Most from College. That was published in American Sociological Review, and a lot of the work that's come after it is dealing with some of the issues that arose in this paper. So The effect of college on wages is a classic economic interest, and there's a substantial literature that looks at the effect of college on wages. I'm going to use this as kind of the running example throughout what I discussed today, but the methods that I'm discussing have wide application to different substantive topics. So much of the work on returns to college assumes homogeneity, that the effect of college on life outcomes doesn't systematically differ in the population. And they want to look at an average effect of college and deal with the identification issues of trying to estimate that causal effect in the presence of a potentially very selective treatment. Heterogeneity, when the effect of college varies across the population, means there's a distribution of responses such that systematic portions of the population have greater or lesser gains than the average person, and potentially the effect of college isn't well summarized by a single number. So what we were interested in this paper, the heterogeneity that we were most interested in was the variation in the effects of college by selection into college. So I'm going to refer to this variation in effects by the likelihood or the propensity that an individual attends college. So that's the selection mechanism that we're going to focus on. And we were concerned about this type of heterogeneity in this study for its implications for social inequality and policy, but also for its focus on differential selection mechanisms, which I'll come back to in a bit. So an influential conceptualization about what we might expect if we attend to differential responses to college on wages was what's been called positive selection. And the idea here is that economic returns to college are governed such that individuals who benefit most are the ones who are most likely to select into college. This is the rational behavioral or utility maximizing model for the choice of attending higher education. And questions about access to college and the effects of college in this kind of framework are intrinsically intertwined. So individuals make decisions about whether or not to attend college based on this rational cost-benefit analysis. So the ones who choose to attend college realize that they have these larger expected gains. So an alternative theory is that of negative selection. What we call negative selection in this paper is that individuals who benefit most may be the ones who are least likely to attend college. And in the sociological literature, questions about access to college and the returns to college are often separated under the justification that or this recognition at least, that many non-economic factors predict who attends college and who doesn't, not just a rational choice based on expected economic returns, cultural, social norms, and circumstances that may govern selection. So we hypothesize that there may be different factors governing college-going behavior by the probability that an individual attends college, that high social background individuals may be likely to go to college even in the absence of a rational cost-benefit analysis. This is the expectation of their educational trajectory that they'll go to college after high school, whereas actually the low social background individuals may have more of an economic motivation to attend college, and there may be greater self-selection factors for that population. So we also drew on this important finding in the social stratification literature suggesting heterogeneity in the returns to a college education. So here we see that there's this kind of slope for college-educated workers, that by socioeconomic origins, the relationship with socioeconomic destinations is not that strong, versus for less educated workers, that there might be a very steep slope between their socioeconomic origins and their socioeconomic destinations. So these are kind of the levels. If we turn attention to the effects of a college degree, then that we see potentially larger effects that we might observe for those with low socioeconomic origins or those with a low propensity to attend college. One of the things that emphasize in this type of chart is that it's the particularly poor labor market prospects of those people who come from disadvantaged socioeconomic backgrounds and don't have a college degree that drive some of this differential effect and potentially large effect for the college-educated workers. So this becomes an important consideration that come back to. So in this study, we looked at the distribution of the effects of college on wages, and we're just asking if there's positive or negative selection using data from the Bureau of Labor Statistics National Longitudinal Study of Youth, which has been used extensively to study the returns to college education. So it's a nationally representative sample of young men and women who are 14 to 22. We focus on the 14 to 17-year-olds when they were first interviewed in 1979, have been followed ever since. And there's a subsequent cohort, the 1997 cohort from the NLSY. And then we adopt a potential outcome approach and ask whether an individual who completed college would have different wages if he or she had not attended college, which of course can never be observed, and we base the identification strategy on this ignorability assumption that we've adequately accounted for all the factors that influence selection into college, which again I'll come back to in terms of relaxing that assumption. So we try to condition on an extensive set of characteristics that predict college. And then what we ultimately do in this project is to examine these empirical patterns of the effects of completing college by propensity score strata. So we're going to generate propensity scores and then group people up into strata using a multi-level model. And this was really the innovation, or the methodological innovation in this paper. So let me say a few more words about that. So what we do is first estimate a propensity score for each individual in the sample, and this is defined as the probability of assignment to the treatment group or college completion given a set of observed covariates. And then what we want to do is group those individuals into balanced propensity score strata. That just means that no individual covariate or the propensity score differ within each of those strata. And then in level 1, we estimate treatment effects specific to each of the stratum, and then in level 2, we pool the results and examine the trend and the variation in effects to see if we have positive or negative selection. And this is based on a variance weighted least squares regression. So variation in the effect of college by the estimated propensity score captures this effect heterogeneity of substantive and potentially of methodological interest. So by focusing on the propensity of college, we offer potentially alternative interpretations of the results based on observed and unobserved selection factors. And this becomes a value, not a detriment in the approach, that we're able to interpret these results in different ways based on selection factors. And so the propensity score covariates are generally probably a few more than this, but family background, ability in academics, social psychological, and then later on we'll see as we expand this list even further to other things that we think potentially might impact college, and I'll come back to how we can best estimate these propensity scores as new methods have arisen to do so. So again, the first step is to generate these propensity score strata. The histogram just simply represents the number of college graduates in purple and non-college graduates in yellow. And so we have 5 strata. This is for men. And then LSY, we have some low counts at the tails of the distribution, but balance across these different strata, and we limit the analyses to the region of common support, meaning that there's no treated units or control units that don't have overlap in their propensity scores at the ends of the distribution. So who are these people? So at the low end, we have individuals with parents with low education, lower measured ability, mother's education being on the lower side, less than high school, those who potentially don't plan to go to college, and then with the kind of the flip side of those with a high propensity to go. So then as we turn to the main results, we just ask our individuals who benefit most likely to complete college, have the highest propensity, or those ones who have the highest propensity scores. That would be if we see a positive slope in the multi-level model, or the ones who benefit most, the least likely have the negative slope. And these were the results from this study for men, where we saw negative slopes for, this is now late 20s to early 30s to mid 30s to late 30s, and that was about what we could observe at that time. Now we have further results for later ages where we see some differences. But so they were somewhat suggestive, but it was quite noisy. So the linear fit of these points is not strong. There were not significant level 2 slopes, and so this kind of propelled some further work in this area of is there a better way to do this? And stirred some debate. So let's see. So what we then wanted to do is to think about alternatives to relaxing the linearity assumption across the propensity score axis. So we developed a different approach that was published in Sociological methodology. The parametric approach was the one that it just showed. And then we had some alternatives to generate some non-parametric smooth curves over the distribution. And so the first was this matching smoothing non-parametric method, and this consisted of the steps of estimating the propensity scores for all the units, then match treated units to control units, and with some matching algorithm. And then you have unit-specific effects, and you plot those differences, those pairs between the treated unit and the untreated unit along the continuous representation of the propensity score axis, and then fit a smooth curve to the trend in effects, some local polynomial smoothing. And the smoothing differencing approach was a variant of that, where we actually smooth out the treated and control units and then take the difference between the two smooth curves. Both of them usually produce similar. So one additional modification I've made recently is to adopt a more systematic procedure to estimate propensity scores. Back when I was first doing this, I did it how was suggested at the time in the literature, was to use the theoretically motivated covariates and then see if the strata were balanced. If they weren't, there was often some indication of which covariates were problematic, and then maybe try a higher order term or some interaction between variables until things balance. And that, I think, worked reasonably well, and actually the procedure I'll talk about today is highly correlated with some of those types of procedures. But here's an alternative way to construct propensity scores. So this is based on an iterative procedure that's outlined in Guido Imbens and Don Rubin's text, their 2015 text. And the idea here is to kind of improve on the specifications that just include all the covariates linearly or kind of make ad hoc decisions, but then also not be entirely black box, and where we can't determine what went into the model and what went into the final specification. So what you do is begin with a baseline set of covariates, and these are the ones that we think a priori have a strong impact on selection into higher education, and that theoretically these are very important determinants that we've seen again and again, and they should be in this model. And so I start with this baseline covariates of a few things like mother's education, ability, parental income. It's kind of a subset of characteristics that you see in virtually every study that looks at the effect of college on earnings. And then in step 2, you consider lots of other possible things to add into the model. So, and then what we do is you add the covariate with the largest likelihood ratio, statistics that exceed some constant threshold that you determine, and then repeat the process. So if one is then added in, then you repeat and look through the set of covariates. So this step involved 176 regressions, and then we had a resulting model of 22 linear terms. And then in step 3, you consider all the possible higher order terms and all the possible interaction terms. So there are 253 possible additional terms. And so then you follow the same procedure as before, where you have some threshold which determines whether that term is added to the model. And that was another 3,500 regressions, what you look through to determine. So this is like a human version of machine learning. And so to do this and then end up with a model with one higher order term, actually out of all that, and 12 interaction terms in addition to the 22 linear terms. And this ends up, it correlates pretty highly with a number of the particular machine learning algorithms that generate propensity scores. But some, I'm forgetting which ones correlate highly. Some of them correlate more highly with just the linear terms, which strikes me as somewhat bizarre, interesting. But the nice thing is that we know which higher order term is in there, we know which 12 interaction terms in there. For me, at least, it's substantively interesting seeing which terms generate the final propensity score, although it takes quite a bit of effort to get there. And then we restrict to the region of common support in this case as well, of course, and I think maybe we lost 2 treated units and a large group of control units on the low propensity score end of the distribution. So we thought that linear specification of the multi-level model was a pretty poor fit for detecting patterns of heterogeneity. So here's an effect of college on log average wage now from 1990 through 2014, where now we're going through to the early 50s. And this is using that matching smoothing method. The new propensity score model, this is men and women actually combined here, who have wages during this time period. And so there's a lot of noise in this representation. But what we've determined are potentially some interesting subgroups are those who have a low, middle, and high propensity score. And that potentially we have kind of a U-shaped pattern of the trend and effects. And some of that we end up seeing is driven by the later life career wages for those with a high propensity who go to college. Their wages really pick up in the later career. And so that's where this new focus has gone. So this has motivated a new study I'm working with Siwei Chang, was here at UCLA. Unfortunately, we lost her, and she's now at NYU. And Chang Zhao, who's in political science at Harvard, and Yu Xia and Michael Hout, who's also at NYU. And so here we're looking at, now we're going to group into three distinct groups, those with a low propensity score, and this is at 0.1. And we're looking at growth curve models for life cycle wages. And here we're distinguishing between college, that's the solid line, and no college, which is the dashed line, and the predicted log hourly wage. So the difference in these would give you the effective college for the low propensity. At the middle, we see a little less, smaller effect of college, and at the high, a large effect, especially at that later part of the career. And so it looks like a potentially U-shaped pattern, which we've seen in now a number of different ways in which that we've estimated this, and some other work that's been increasingly showing some U-shaped patterns for different types of ways that they've looked at heterogeneity. So another question we wanted to address is to what degree this is just by propensity score strata, or if we'd see similar patterns if we looked at other key axes of difference or key covariates, so like parental income or ability. And so here is now by parental income. This would be the bottom third of the parents' income distribution versus the middle and the high. Here we particularly see some large effect for those who have low parental income in their family background. And notably, this pretty flat wage trajectory for those with no college degree who have who grew up with low parents' income. Somewhat similar here in the mid. There's more of a slope there for those with high parental income, but again, that pretty high slope for those with who go to college. And this is now for ability, so the bottom third and the middle and the top third. So in pretty similar types of patterns as the propensity score strata. And generally, when we look at these differences, we see kind of this U-shaped pattern where larger over the life course for low ability when we've looked at cumulative wages or these kinds of things. Okay, so as I mentioned, by focusing on heterogeneity we've been doing by the propensity score, we're asked to what degree can we interpret the pattern as due to representing difference in effects by this observed selection versus unobserved characteristics of individuals. So some unobserved factors might reflect individuals' resistance to college. So we might have this U factor that also determines selection into college, but it's about their unobserved resistance. So we can think of the latent college function as being a combination of both the observed factors and these unobserved factors, or the unobserved resistance. And then that we might define the effect as the marginal treatment effect for the college on wages as a function of both P and U. So if we do that in this figure here now, and this is from a paper that's in Press, a Journal of Political Economy, from my co-authors on the prior paper, Shang Zhao and Yu Xia. So in this paper, darker blue shaded regions indicate larger treatment effect magnitude, and the yellow is smaller, so larger effects of college on wages. And under the ignorability assumption, we have this special case where the treatment effect could vary by P, but not by, or we're not thinking of it varying by U. So substantively, we take lower resistance to indicate that individuals choose college because of anticipated high returns. High resistance would be because they don't anticipate that it's going to pay off for them. So we expect that lower observed propensity for college is associated with lower unobserved resistance to college and higher observed effects. And so you note the correlation between P and U. This would be just among treated units, so that most of the ones who have a low propensity for college are coming from those with low unobserved resistance. And then those with a high propensity for college have more variation with respect to that resistance to college. And so in the analyses have been showing thus far, we've just presented simple results pertaining to P, right? We haven't really considered these values of U. So the patterns that we've looked at by propensity score strata are informative in their own right, in the sense that if ignorability is true, we can interpret them as indicating that the effect of college is a function of the likelihood of college. If ignorability doesn't hold, and we have this variation by U, which in the case of college education or very selective treatment, we think that there could be sources of heterogeneity that we're not attending to, but then the results still have an interpretation in the sense that they indicate variation in effects by the latent dimension of unobserved resistance to college. And then importantly, if we focus on the diagonal, we find that among students who are at the margin of indifference between attending college or not, those who appear less likely to attend college could benefit more from college. So even in this case of considering the unobserved factors, we could observe this greater impact of college for those with a low likelihood. So the sorting on gain, or the theory of positive selection, is the very thing that actually causes the observed pattern of negative selection and the results that we've shown. This has implications for public policy when we think about expanding college to those on the margin across the propensity for college. So we have expected gains that are smaller if we include more units who have a higher observed propensity for college, or larger if we include more individuals who have a low observed propensity for college, or even just focus on that subpopulation. Okay, so the discussion thus far is focused on wages, and if I return to this hypothetical drawing, even if we increase the slope for the college-educated workers, which I think is probably going on, especially later in their career, or focus on this kind of U-shaped pattern, we're still left with this interesting result where the less educated workers, and we've seen this across a lot of the work that I've done, have these particularly poor labor market prospects. And so if we're looking at wages, we're getting this result for the low propensity college goers because of this alternative state. So this led to thinking about, which is the basis of a book project that I'm working on the way in which college circumvents low wage work and other disadvantaged states for students on the margin, or for low propensity college students, or those more disadvantaged. So what if instead of looking at a continuous measure of wages, we instead look at something like the proportion of time that individuals have spent in low wage work? So that's what turn to now, is to look at not wages per se, but low wages. So the way in which college impacts avoiding or circumventing low wage work. So this was the result using the matching smoothing for the log average wage. This is now if we look at the proportion of time in low wage work, and here you'd want to see a negative effect, right? So that you see a positive slope is actually a negative selection kind of story, in the sense that that college circumvents low wage work more so for those from more disadvantaged conditions. So in the book, I focus on a lot of different outcomes. So low wage work is one, job instability, poverty, receipt of welfare, even things like single parenthood with the AMBER, and others. And that's often, this is generally the pattern, that you see this kind of strong effect for the individuals who have more disadvantaged backgrounds, lower ability, and so forth, who go to college, that we see a larger effect for the circumventing some of these outcomes. So we also wanted to go back to kind of these three category stratified effects now, but focusing on low wage work. So here I'm going to build out a heat map. And this is based on work with Pablo, who's in the room here, and another graduate student at UCLA, and Bernie Koch, and another one, Xiaowei Xu, who's back east right now, but who's also worked on this and has a degree in economics from UCLA. And so we're going to build out the kind of a color coding, where the red indicates higher treatment effects in the sense of larger negative effects of college on reducing low wage work. And as we move towards blue, we have smaller effects. This is a three category propensity score characterization, so low, middle, high. And then we can kind of build this out with a number of different covariates. So what we wanted to do is see how the pattern reflects across a number of, and I know that's really small, but that's to build out the seat map ends up small. So this is the propensity score square, and then we're going to have it's even small for me. It's going to be ability, parental income, mother's education, and then a 3-category for race. So here we see by ability, still strong effects for those with the low ability, moving more purple as you get higher ability, and that's parents' income, mother's education, and race, where we go black, Hispanic, white, just given the proportion who attend college, we kind of ordered it in that way. And then we can also just look at the cross between some of these characteristics. So this would be ability and propensity score strata. So again, we see these patterns where those in the lower left cells tend to have the reddest effects, and then we get more purple and some blue towards the more advantaged states, and that's what we generally see across the whole heat map. So stronger effects for those with more disadvantaged conditions, and some interesting patterns where some like this low propensity score but high ability have some smaller effects, or there's some things of note, but mostly that's the pattern that we see. Okay, so this leads to the kind of final segment. So in each of these demonstrations of heterogeneity, we relied on kind of a priori generated categories of interest. And so what we've asked in this recent project is what sources of heterogeneity might we be missing by focusing on things that we think are important sources prior to the analyses. So I wanted to end today with this new approach using recursive partitioning based on machine learning to determine subpopulations of interest. And so with this kind of perspective, we generate subgroups that may or may not accord with some of our theoretical priors. So I'm going to use machine learning-based regression trees to recursively partition the population, and do that in order to maximize heterogeneity across groups and minimize heterogeneity within groups or within leaves. And I think several people were at Susan Athey's talk last week at CCPR, where we've been kind of building on those causal trees that she presented last week here on campus. And the idea for these is that we're going to use regression trees, which are non-parametric approaches to fitting model through recursive binary partitioning of the data. And the single covariate and threshold are selected that minimize the in-sample loss function, the mean square error within the data. And the sample then gets split into 2 new partitions when it does so. The process is repeated and recursively within each partition, and then we can constrain the depth of the tree through some regularization parameter. We restrict to the number of treated units and the number of control units that need to appear in each leaf of these trees. The regression trees are an attractive tool, I think, for social science applications. I found them really compelling in the sense of just that they're not black box. They're very interpretable. Despite being non-parametric, it's very transparent, the criteria that are used, and so I think they have a lot of potential appeal for a way in which to explore some sources of heterogeneity. So this was key to me, to just be able to see what was going on and look at the actual tree, even though some regression or random forests and other things might have some other more some desirable properties. So there's a rapidly growing literature, and that's bridging machine learning techniques with causal inference. And the causal tree algorithm was initially proposed by Susan Athey and Guido Imbens in a recent PNAS, the Proceedings of the National Academy study article. And so it's an adaptation of regression trees for causal inference. Describe this as causal trees. We attempt to systematically partition the data in a way that minimizes heterogeneity in the estimated treatment effects rather than the outcome. So in other words, we predict not the outcome, but the effect, and doing so requires changing the objective function of these regression trees that are, because there's no real ground truth, right? They're in the potential outcome approach, we're limited in the sense that we never know the outcome, the treated and control state outcome for any unit at the same time, and so we don't have the same kind of ground truth as we do when just predicting an observed outcome. So we have this modified mean square error loss function, and which is the difference between each unit's treatment effect, this estimated treatment effect, and the average treatment effect within the leaf. We split the data, so we use a training and test sample to achieve honest estimation. So in this case, I'm going to apply this to the same data and question of interest, looking at effective college on low-wage work. So we have roughly 4,100 cases. So we're splitting and then building the tree. So at some points we get into some small cells. And then there can still be, so a lot of this work is based on looking at experimental studies. We're going to use this in this observational context. And so there can still be considerable selection within each of the leaves. In this case, we use propensity score matching within leaves and potentially use other types of identification strategies for the leaves. But for the most part, we're trying to just kind of uncover sources of heterogeneity that we may not have thought of prior to our analyses. So if we start building the tree, and that's probably small, but that's mother's education became, so the first cell, and this is going to be color-coded in the same way as the heat map, where we have red leaves now are going to be the largest treatment effects, and all the way to blue. So for the full sample, we have something that looks somewhat purple. That's a negative 0.17, so reducing the time in low-wage work by about 17%. And so that's the full sample. Then the first split is going to be on mother's education. And so for mothers with less than a high school degree, we see red, so the stronger negative effect of college on reducing time in low-wage work. And that's about a little more than a third of the sample, so about 38% versus about 2/3 of the sample where we see a smaller treatment effect. And then the next split on this left side of the tree is by number of siblings. Here again, see a larger effect for those with come from larger families. So this will now be mothers who have less than a high school, individuals who have mothers who with less than a high school degree and had at least 2 siblings. And then here we have this negative 0.27, smaller effects in the other divisions. And then we could potentially split again. And what ended up being split on over on this side of the tree was social control. So this is one of these psychosocial indicators of locus of control. And here where we have high levels of low control, then we see even a larger treatment effect. Now we're down to about 16% of the sample, negative 0.34. And here it's all, there are some significant negative effects on low-wage work, but somewhat smaller than what we observe on this left side of the tree. And then we get some interesting kind of patterns for, so the mothers who have a high school degree, but then there's this split on parents' income, where to the left now we have lower levels of parents' income, and then moving through here some low levels of social control. School disadvantage is another indicator, so getting down to that. So among those mothers who have a high school degree, or among those individuals with mothers with a high school degree, the ones who have lower parents' income, lower social control, more school disadvantage, then we start seeing some of these negative effects on somewhat similar magnitude to this other side of the tree. And we could keep splitting. By the time we're getting down here, then we're really in a small sample size. So I think some of the interest is just some of the things that are split on that we may not have thought of prior to this type of work. So we were splitting on mother's education, we were splitting on parents' income, and that was kind of the basis of some of that heat map, but maybe not at some of these thresholds. And we wouldn't have considered potentially family size and social control and the combination of these things prior to the analysis. And actually the full tree looks like this, where we have this kind of strand of these bluer effects down there. And then, so we've been trying to figure out ways to best visualize some of these trees. So here's just a few additional alternatives that my co-authors have been coming up with. So one way is now, this is going to be the same tree, but just different data visualization techniques. So this is the pie is the full sample, and red indicates treated units, blue indicates control units. And then as the pie shrinks, that's relative to how large the sample is. This stacked bar chart shows the response, the low-wage work, the distribution for the red, the treated units, and the blue, the control units. And then we could keep splitting as we did before and start seeing, as the sample size kind of diminishes, and just it's a different kind of set of diagnostics that we might look at, and it would keep building. But and this actually works better in HTML when kind of it builds out and splits nicely. And then here's one further modification that we started playing with, is just having the data points kind of slowly come through the tree, and here they're color coded until they get to the final leaf. Really, she just made this a few days ago, so we're toying with different ways of kind of producing these trees in a more visually satisfying way. Okay, so just say a few kind of concluding remarks. So heterogeneity in response to a common event or circumstance or intervention is quite common. It's unreasonable to think that individuals respond identically to all the events or situations that occur in their lives. And the key is, how do we determine meaningful sources of heterogeneity, and how do we interpret patterns and effects across those sources of heterogeneity? So one long-standing approach in the social sciences is determine subgroups of interest who we theorize should respond differently to different types of treatments. And there are a lot of advantages of doing this, because we have a lot of theoretical interest potentially of between blacks and whites and how they respond to the going to college, or between men and women, or between more disadvantaged individuals versus more advantaged, or by the likelihood that they'll actually go in terms of the distribution of scarce resources. And this, then it gives us insight, especially focusing on the propensity score, as we've done for a lot of my work, focuses this attention on differential selection issues. So all those decisions about what subgroups to explore are based on kind of researchers' decisions prior to analyses, and so-called. So a lot of work that goes on behind the scenes is that people go through regression after regression and look at differences and effects in a somewhat non-systematic way, and try to determine whether there's actually interesting interactions that we should be looking at. And that happens, pretty commonly in our data analysis. So one solution is based on these machine learning algorithms to study causal effects and discover other sources of heterogeneity in a somewhat more systematic way. So we're able to determine different subpopulations that we may not prior considered. We do this cross-validation, look at test data and training and test data, and then uncover sources of heterogeneity rather than kind of doing that in a more ad hoc way. So what have we learned about the impact of college on wages through this kind of journey over looking at all these different sources of heterogeneity? I think by doing this, we focused more attention onto differential selection patterns. a lot of the work on heterogeneous causal effects looked at differences by key covariates, and often there's not a lot of attention paid to the different ways that individuals select into college and how that can impact those observed responses. Looking at the different counterfactual pathways by these different characteristics, especially the propensity, has helped us think about new things to study. So like looking at low wages versus looking at wages in a continuous way just came from observing all these different patterns and thinking about the differences between college and non-college across different stratified covariates. And then the causal trees, I think, have helped me highlight particular subpopulations who vary, who we may want to focus on or target or design policies, particularly for certain subgroups of interest that I might not have focused on previously. So I'll end there. Thanks.
With that, we'll open it up for some questions. So I guess I like the idea of so like at the beginning when I was thinking, like you show like high propensity, low propensity, and heterogeneity across that propensity score, but then you think like, well, what combination? There's lots of combination of factors that can make me a high propensity individual or low. And I think that with the trees, I think it would be interesting to see maybe even just like descriptively in those plots with the distributions, like the distribution of the propensity, because I think it'd be nice to know, like, among these high treatment effect groups, are they, like, what's the distribution of high propensity individuals? And I think it answers two substantive questions that I often encounter when I think about those two processes, which is like what leads to the selection, but also what leads to the heterogeneity. That a lot of times, particularly I feel like the machine learning techniques like leave us like wondering why is the effect, like who is this effect large for? And I think you're right that please help with that, but it'd be awesome.
Yeah, I think that would be a good diagnostic to include in one of these plots too, is to have the average propensity score in each of those. So at the end of the tree there were some propensity score splits, since that's included in the model as well. And one I didn't show, we built this tree for a proportion of time in unemployment, and that's the first split was on the propensity score, and then so you see how it plays out there. In general, those ones on the left were the lower propensity, so it maps on pretty well to propensity score, but it'd be nice, I think it would be a good idea to just look at the some measure of the propensity score. And
I think for the generalization, like people thinking about generalizability and thinking about targeting the policy relevant questions.
Right. And as soon as we start adding in the propensity to some of those leads, then we have this can also build on the interpretation about unobserved selection, and
So my question is for the last part. When you say you use machine learning to do recursive partitioning, did you treat it as a supervised learning problem by using the propensity score as the response?
Yes.
Okay.
Yes. Yeah.
So you hear a lot about difficulties of people that generally would fit into the left side of a bunch of those plots if they end up going to traditionally selective colleges. And you also hear about certain colleges specifically reaching out and offering resources for people who may have less resources from their families. Did you look into at all how perhaps some of this can be driven not just in what happens in leading them up to whether or not they go to college, but also where they choose to go to college, and how that might affect heterogeneity? Yeah,
so we've constructed, in various different papers that I'm working on, constructed all sorts of measures of college. So here I simplified it just to look at 4-year college completion, but we have community college attendance, any 4-year college attendance, college selectivity. So we have all these measures that we can look at. In general, the ones who are more disadvantaged tend to go, so this was all 4-year college completion, so they had to end up at a 4-year school, but most of the time they're at less selective 4-year colleges. Now, increasingly, we have thrown in the mix the for-profit colleges, which brings on a whole new layer of thinking about disaggregating the types of colleges people go to. So I've done some of it by college selectivity. Generally, we see similar types of patterns in the sense that the people who have a low propensity for attending an elite school tend to have higher impact as well. But again, there's a very selective group of people who come from more disadvantaged backgrounds and end up attending an elite school. And then we look at graduate school too, kind of how many people go to graduate school subsequent to, so the high propensity tend to be the ones who go to more selective schools and go to get a higher degree. So that's where we see this wage growth, really high wage growth load later on. They don't often major in things that are the most quick payoff. So the social sciences or humanities, but then we see this kind of long-term payoff.
Thank you.
So to follow up on that, would your method be in theory producing recommendation, like personalized recommendation for what kind of treatment, what kind of people would need? Like, as in the sense that there's this movement towards personalized medicine. So now the same drug doesn't work for everybody, so maybe some kind of education works for some group. Did you have thought?
Yeah, no, I haven't thought much about that, but potentially the more you build those kinds of causal trees and you get into some very targeted populations where, yeah, I mean, I'm always a little reluctant to go quite that far given all the selection issues that are inherent in this type of work. So I always pause a bit in terms of the policy implications, although I tried to lay some of that out, that even if there are selection factors, the ones who kind of end up selecting in are the ones who would probably benefit. But potentially, I think that is an interesting way to frame it. In the book now, I've been constructing these kind of vignettes based on the data where I'm taking really personalized groups out of the leaves. So like we identify these leaves and then I kind of subsample a treated and a control unit and just follow them and describe their trajectories, which actually works pretty well for representing what happens. So then it becomes very personalized in some way. Yeah.
So with the trees, I guess in your experience, I'm curious, how do you think about there's clear advantages of letting the data speak to what could be a possible moderator, but then there's like this, I'm curious how you cross this bridge of like possible post hoc rationalization of, and how do you think through as we go forward investigating these kind of odd groups that might pop up, like, I don't know, like you said, like the number of children was that's
right.
What a priori thought of, and how should we think about that and bring in theory, and how do you approach crafting that?
Yeah, we're kind of struggling with all of this as we've been going through it. So in some ways that's why I've been focusing on the higher up splits, because as you keep going down into the depths of the tree, it becomes a very targeted population. That's, yeah, what exactly are you going to say about someone whose parent income was less than $15,950, or these splits that somewhat start seeming somewhat arbitrary. So we've been focusing kind of on the higher up because it yields a few subgroups of interest. And I think when I was talking about this with Susan Athey last week, who was developing this, she was saying, it's best to just think of these splits as subpopulations where you start looking at the range of characteristics in the same way that you do with when you partition by propensity score stratus. And some people have trouble thinking about people with the low propensity. What does that mean? Well, we can give these average characteristics of that group within that subpopulation. I think in some ways you can do that here as well. So maybe the things we split on are of interest that we might not have thought of, but really once we hone in on a particular subgroup, then we want to think about the full range of characteristics. So like in that tree, there was no split on race, which was in some ways surprising, but then at the same time, well, these people on the left-hand side are, predominantly Black and Hispanic, and or higher, greater proportion of Black and Hispanic, and so it's not as if that's not an important factor that we should be focusing on. So I think, it's just building some of the things like social control has come up a number of times, especially when we were looking at single parenthood. And so the work that Amber and I have been doing, and it becomes very interesting. So like it's a group with low social control who came from large families, maybe non-intact families. So there's a couple of things that split on for particular outcomes that are substantively interesting and kind of maybe yield new theories about what we should focus on.
All right, thank you, Jenny.
Thank you so much. This was fun. Thanks.